plan. We've got this nice new idea for a scene for detecting what's happening in the conflict regions in alternating strabism. Left eye sees this white grid on a transparent background, and now we have these indicators also in the center, and we do it for each eye. Right, lovely. Next, we will have these panels slide in from both this edge and this edge towards the center and disappearing through the center into nothing, and vice versa, depending on the head moving left or right, where up and down still controls the relative luminosity. That means we can experiment with low amounts of visual stimulus, massive amounts of visual stimulus, as in when both panels are fully visible, and the movement of the panels from non-conflicting zones into conflicting zones and back through conflicting zones, only in conflicting zones, and into non-conflicting zones, and see what phenomenon we see. And still have the grid references to be able to identify where the phenomena are through the fact that these two panels are almost white, but they're slightly off-white. So we will see the impossible colours where we have the actual fusion taking place, or the brain is processing an overlap. So this little rig can do a load of interesting stuff. Now, in terms of implementation in the framework, I think the best way to do this, we're going to have these new asset packs here in the left and the right eye. Now, when the asset swapper enables this, I'll have a component in here that detects when it's been enabled, and in turn is hooked into, wired into the binocular suppression controller, where we have a component here, and that component is going to be responsible for driving the position of the panels in the left and right conflict areas inside here. It'll know about them and be wired in. And so it'll be enabled and disabled here, so it's orthogonal to everything else. And as long as this component is wired in to the same camera as here, we don't have any extra overhead. And when we look actually here, we see that at the moment we are in the headset. We are only getting calculate direction around the x-axis, which means looking up and down. So this is a mistake. This needs to get horizontal direction. Actually needs to be refactored. And we need another method, get vertical direction, which is, as long as it's referencing the same instance, not actually got any overhead because it's a separate calculation. So we can actually start right here. Anyway, I think that's a plan.